Okay, so to find the circumference of a circle with a diameter of 6 centimeters, our diameter equals 6, we're going to use circumference equals pi times diameter. You want to use your pi button. Okay. So find your pi button on your calculator. If you don't have a calculator, you might want to get one. Okay, and the circumference is going to equal 6 and about 3 and 1/7 of 6. So it'd be 18.85, and it would be centimeters. Any questions over that? That's it. Okay, find the circumference given the radius now. So since we have the circumference, we have the radius this time, we need to take 2 times the radius times pi. So 2 times 7 would be 14 times pi. And again, it's going to be about 3 times 14 times 1/7. And that's going to be 43.98 inches. Any questions over that? Yes. You could. Yeah. It doesn't tell you how to round it, so I just ran it just to get the close. Okay, find the circumference of the circle. What is 12? The what? What part of the circle is 12? So 12 is the length of the side of the square, but how does that relate to my circle? We need a radius or diameter. What would be the diameter? 12, right? Let me try it again. So it's like that side would be 12, and the diameter would also be 12. So we would use the circumference equals the diameter times pi. The circumference equals 12 pi. So the circumference is going to equal 37.70. That's a 3. questions in that? Okay, the next one is going to be find the radius of a circle if the circumference is 52. So we're going to work backwards. So this time my C equals 52, and the R is a little simpler. So we're going to use our formula circumference equals 2 pi times the radius. So we're going to have 52 equals 2 pi r. Okay, we're going to divide both sides by 2. So that's going to give me, I'm going to move this over here, 26 equals pi times the radius. So I'm going to divide both sides by pi. So then this will cancel out and get my radius equals 8.28. And then into. Any questions over that? It's fairly simple. Okay, arc length. A portion of the circle of the circumference of a circle. You can use the measure of the arc in degrees to find its length in linear units. Given all circles are similar, we're going to find A prime, B prime. So every circle is similar to another, because the definition of similarity is that all the angles are congruent. Okay, are there any angles in circles? No. And then that their sides are proportional. Okay. We don't have sides necessarily in a circle, but we do have the radius. And the radius and the diameter. And the radius and the diameter will always be proportional because, let's try this. So 4 over 6 would be the radius proportion. What would be the diameter of this smaller circle? 8. Jeremy, what would be the diameter of this circle then? Of this one? 12. Now would they both reduce to the same thing? 4 and 6 can both be divided by 2. It would be 2 over 3. 8 and 12 can both be divided by 4. So that would also equal 2 over 3. So they have the same ratio. So that is our scale factor, and that proves they're similar. So seeing that these two circles are similar, we can find this piece of it. We are given that this piece right here is 2.8. Since their central angles are the same, these two sides should be proportional. Not congruent, but proportional. Okay, so we're going to use our scale factor of 2 over 3 is going to equal the arc length here, the length of AB in the smaller circle, over this arc length here, which is my unknown. Any questions over that? We're going to cross multiply. We're going to get 2x equals 2.8 times 3. Then we just divide that by 2, divide that by 2, we get x equals 4.2, and that's the answer. So, the length of arc A prime B prime is equal to 4.2 meters. Yes.
I think you just feel like the soil standard.
Okay, and how did you do it?
And here, switch over to working ratio.
Okay.
So you just equal x over 2.8 and cos multiply.
You did use the scale factor, you use the scale factor reduce. That's fine. Okay. And you could use either one. You could do the 8 over 12, the 4 over 6, and it'll be the same thing. Any other questions? Okay. Now that's nice if I have similar figures. Okay. However, in life I probably won't always have similar figures. Okay, so how could I find the length of that arc if I just had the central angle and the radius? It's nice because I can find the percentage of this piece, of my whole thing, just by giving the angle. Since I've given the central angle, I can find what part of my circle is this arc, right? And then I can find the part, that percent, of my whole circumference, that would be that missing piece. Does that make sense? Okay. There's a formula in a circle. The ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the central angle, to 360. So what percent, of my central angle is that circle, to that circle, will be the same percentage that the arc length will be to the whole circumference. So you can memorize this, or no, you're going to find the percentage of it. So the central angle, in this case, is 124, and there's 360 degrees in a circle. And that should equal the arc length, which I don't know, over the circumference, which would be 2 pi times the radius of 7. And I could do this a couple different ways. So you could cross multiply. I'm going to do it a little different. I'm going to divide this and find what percent that is. Okay, that percent, about 34%, I'm going to leave it as a decimal because we're not done using it. Okay. Now I want to get that x by itself, so how do I get rid of the 14 pi? Very good. It's being divided, so I need to multiply both sides. So I'm going to multiply both sides by 14 pi. Don't clear out if you've already done this, don't clear out your calculator. Leave that big old long number because it's going to be a lot longer than what I just rounded to. And I'm going to times it by 14 pi. And I'm going to get x equals 15.15. The length of this arc right here, BC, is 15.15. Any questions over that? Well, I want to find the central angle before I go into my formula. Okay, so this is the diameter because it goes to the center. This part is 180, right? If I subtract 180 minus 120, then I'll get the central angle. Angle DBC is an equal 60 degrees. This is my central angle here. So then we need the formula, which is the central angle divided by 360 equals my arc length divided by the circumference. By the circumference. So I just found my central angle to be 60 degrees. The arc length is what I'm looking for. Over 2 times, let me give it, oh, the radius, say that AC is 10. So we just need 10, we don't need 2 because they gave us the diameter. So 10 times 5. Any questions over that? Okay, I'm going to divide those two. And I'm going to get 0.16 to the line above it. So I'm going to have to multiply both sides, not extra, by pi. So multiply both sides by 10 pi. Don't clear out your calculator. Leave that big old long number, 1.66666, in there. And just times that by 10 pi. And so my arc length is 5.24. And then this would be 10 meters. Any questions over that? Okay, we're going to find the circumference now. So on this, they gave you the arc length. They want you to find, well, first you need to find the radius or the diameter. Use that same formula. The angle divided by 360 equals the arc length divided by the diameter pi. find the diameter. Any questions over that? Okay, so I'm gonna fill it in. I have my central angle of 60. Over 360 equals the arc length they gave me of 3.82 divided by diameter. Okay, we're going to divide that. It's the same as the one before, so it's just 0.16 with the line above it. But put it in your calculator so you have it there, because you're going to multiply and divide in a second. Okay, so now my calculator I have 1.6. Yeah. So they're asking us to find, because they gave you the arc length of ST. And the other one, they were asking you, they didn't ask you for AD, the arc length of AD. They asked you for the arc length of DC, so you need their central length. Does that make sense? Okay, so you can do this a couple different ways. Let's cross multiply it, probably the easiest way to do it. This times this, and bring it down, and then this times this, and bring it down. So I'm going to multiply 0.16, so that thing in there times pi. And I have 0.52 times the diameter equals 3.82. This is a D, sorry. Okay, now leave that number in your calculator. Okay? You want to divide both sides by that 0.52 and that big long number. How you do that? You're going to do 3.82 into your calculator. You're going to hit divided by, and then somewhere on your calculator you have the word answer. Okay? Find that. You usually have to hit shift because it's above the button. And that's how you avoid rounding a button. And I got diameter equals, yeah, 0.30. And again, this should be inches. Any questions over that? Yeah. Okay, so you round it, right or no? Track. You have arc length. So here's how you find the length. Okay. The curves at the end of the track are shown are 180 degrees of a circle. Okay? So it's basically this curve, the central angle is 180 degrees. That's what that means. Okay, the central angle is 180 degrees. The radius of the circle for a runner on the red path shows 36.8 meters. And about how far does the runner travel to go once around the track? Down to the nearest tenth of a meter. Okay, so we're gonna do the guy going around the red path, and not the guy going around the blue path. Does that make sense? So we first know that the straightaway is 84.39. The straightaway here would be also 84.39. What we need to find is the distance around this curve and the distance around this curve. Since the central angle is 180 degrees, when the two arc lengths going to be together? What part of a circle it is? What's 180 degrees? What part of a circle is 180 degrees? What percent of a circle is 180 degrees? Half of a circle. Does that make sense? And what do two halves make? A whole. So really all you need to do to find this part and this part is find the circumference of the whole circle. Does that make sense? So we want to find the circumference, which is 2 pi times the radius. They gave you this radius. Okay, so our circumference equals 2 pi times 36.8. Let's find what that is. I got 231. And that's in meters. So around here is half of that. So this is 115.61, and this part right here is 115.61. This part is 84.39. This part is 84.39. So we're just going to add it all up. So this plus this plus this plus this. This is 84.39. So I just do 231.22 plus 2 times the 84.39. And any track runners in here? No track runners? Have seen any runners track? What's that? 400 meters. Once around the track, it's 400 meters. It's pretty nice. And that's what we just did. Any questions over that? So easy, right? Okay, so let's look at your homework.